Don't forget to like, subscribe and share this video. Let's summarize the lesson. A vector is a quantity that has magnitude as well as direction. You see here is from A to B 3 meters, just simply given, and when a direction is just specified using what is known as an arrow, we can get here this is a displacement vector. You see here a displacement of 3 meters, which is east of north. This is just a representation of this one. The length of the arrow is just describes the magnitude, and the arrow head is just direction. Vector AB, or you can write this as A in general. The magnitude of this one is the absolute value of AB or absolute value of A. You can see here different types of vectors. Here is just concurrent vectors. Concurrent vectors are vectors that are just passing through the same point. O is a point, and collinear curved lines are just two vectors which are just traveling in the same direction. You can see here on the same line. And also these vectors can be just parallel vectors. When do we say two vectors are equal? Two or more vectors having the same initial point is co-initial vectors, and these vectors are just acting along the same point, and we can say that they are concurrent vectors. You can see here two vectors, here AB and CD. Two or more vectors parallel to the same line irrespective of their magnitudes and direction. We have a name. This name is collinear vectors. You see, they are just collinear vectors. They are just parallel and have same line of action. You see, AB and CD are just collinear vectors. You see here, the magnitude of AB is equal to the magnitude of CD. These two vectors are just equal since they have the same magnitude, the same direction, and don't forget that the third one is they must be the same type of quantities. You can make two vectors are just equal if they are force and force, acceleration with acceleration, velocity with velocity, displacement with displacement. You can't make two vectors are just even if they have just equal magnitude, since they are just different direction, different quantities, we can't say that they are just equal vectors. For example, displacement and velocity, acceleration and velocity, momentum and force. You see here, parallel displacement of vector doesn't change its magnitude and direction. You see, if they are just parallel, no change in direction and magnitude. You can see here AB, A prime, B prime, and double prime, B prime. Compare two vectors now here. You see here, we can connect these vectors. Negative of a vector. When you say a negative of a vector having the same magnitude but opposite in direction to that vector. You see, this is just CD. You see, now this is just negative of vector of CD. The same magnitude but opposite direction. DC, the negative of the vector CD. You see, DC is the negative of CD of a vector. They are equal in magnitude but opposite in direction. Also, EF is just the same as negative of CD, or EF is equal to DC. This and this are just equal. Now when you sum up these things, equal vectors have the same magnitude and direction, and you can see here, then we can add a vector. Now you see there is a representation of a vector, and we can add a vector. Let's see example here. Sketch a displacement of 20 km eastwards. You see here. Now you can see here, to draw your sketch, first you must have to have here the direction. This is the east direction, this is the west direction, and this is the north direction, and this is the south direction. So the question is, sketch a displacement of 20 km eastward. Eastward is to the right. So you can take here, this is 20 km. The direction is eastward. You can see here these things. Let's take another. Sketch a velocity of 40 km per hour at 37 degrees south of east. Again, you have here east, west, north, and south. Now you can take here, this is the direction of east, and here you have 40 km per hour at 37 degrees south of east. Now you can see here, this is the magnitude of 40 km per hour, and it is just south of east. It will go to the south, but in the direction of east. So you can have here 37 degrees. This is the sketch or the representation of a 40 km per hour at 37 degrees south of east. You can see this one. Sketch 50 degrees north at 53 degrees east of north. Now again, this is east, west, north, and south. Now you can take here that 50 Newton, then it is 53 degrees east of north. It will go the east but north direction. This is 53 degrees. Will come to the east but in the north direction. Then let's go to another example. What is the magnitude of the vector 50 km per hour at 37 degrees south of east? What is the magnitude? Now you can see here that the answer is just, this is the magnitude, and this just describes the direction. So the answer is 50 km per hour. Now let's see here another question. Decide if these vectors are equal. Now you can see here, when we say two vectors are equal, we are not saying that only here the magnitude is the same. They have the same magnitude. And the same physical quantity, which means it is just the unit of velocity. This is also velocity, which is true. The thing that we have left is the direction. Here you can see in both cases, the direction of this one is, the first one is, this one is north, and the direction of this one is east. So the two vectors are not equal because they have different direction. Let's see another here. Decide if these vectors are equal. Now here, you can see here, both are just showing the same direction. You can see same direction. True. You can see here, same magnitude. What is the difference? The difference here is just this is a displacement vector. But this one is velocity vector. To say two vectors are equal, first they must have to be the same. They must have to have the same magnitude. Is they have the same magnitude, 15 and 15. The other is they must have the same direction. Yes, they have the same direction here, which is just nearly to the south of its direction. And the other is the same type of physical quantities. This is displacement vector, this is velocity vector. So they are not equal vectors.